Well, I hear your dog, but I lost your video.
No, we're broadcasting. I'm still here. I'm just okay. I'm just checking YouTube to make sure the stream is actually started. So now that I see that it has, let me
Oh,
do.
so henceforth, all things that are
Yeah, you're
said will
live,
be
so we are
okay.
here. We are hearing you. Hey, everybody. Okay. Thank you for your patience. First of all, it's 15 minutes after I said I was. Oh, no, it's 10 minutes after I said I was going to start this stream, and it's because of a real operator headspace error. I was worried about sound, but turned out sound was coming through. Anyway, my name is Tony Darnell. I work at deepastronomy.space. Hopefully, you guys know that by now. And this is a special stream. This is usually Spaceman News Day, and it still is. Don't worry. I've got Spaceman News ready to go. I'm going to upload it after this stream. So we'll have that to look forward to after this is over. But I wanted to kind of share something with you guys about an idea that I had day before yesterday. I was watching Cosmic Lettuce on his stream, and if you haven't watched his stuff, you got to check it out. He's got a daily stream at 9 o'clock Eastern time every day. He gets up there and streams about astronomy, and I was watching it on Wednesday, and he was talking about coordinate systems, and I was at the same time thinking, boy, it'd be great as if we could get Worldwide Telescope on this to maybe talk a little bit about coordinate systems. So while he was talking and having a great stream, I was playing with Worldwide Telescope at the same time, and I wanted to take a minute and introduce you to Worldwide Telescope, but I got this idea for a contest because I wanted to pull up the Horsehead Nebula and look at it. And I knew that the Hubble Space Telescope had taken a really nice image of the the Horsehead Nebula a couple of years ago for one of their anniversary images. It was in the infrared and it was just gorgeous. And I wanted to put that in Worldwide Telescope because it has this really cool feature in it that lets you fade back and forth between different images and look at what things look like in different wavelengths. And I'm going to give you a quick demo here of this in a minute. But I had this idea of adding this image, and so I tried to add the image myself. I went to a website. I looked at how you add images into Worldwide Telescope, and then I went to a website who claimed to have images that were compatible with Worldwide Telescope, and I downloaded one, and I tried to put it in Worldwide Telescope, and it didn't work. And it turned out we needed more information in the header of that image. And I'm going to talk about the details of that in just a minute. Now, also in the description of this stream, I've tried to lay out most of the problem, but we're going to be going over this in detail during this stream, and you can refer to it when we as you go on, and maybe if you try to do this contest, you'll be able to do it. But the story goes that on Wednesday I had this idea. I presented it to people on Thursday, and by this morning, Judy Schmidt, whom I'm going to introduce you to in just a minute, had already solved the problem and won the contest before I even put it out. But don't worry, I still want more of you to do this thing, and there's prizes involved. But Judy's here in the Hangout with me, and she's going to help guide us through some of the things that she went through to get this done. So let me first of all, hi, Judy.
Hello.
She's a disembodied voice on this because she wants to show us the steps she's got, and she doesn't have a very good webcam at home. So she's joined us auditorially, and she's sharing her screen with me, and I'm going to show you all of that here in just a bit. A couple things. If you want to interact with us, let me pull up. What do I got? Oh, the best way to do it. So I'm streaming in all the normal places, all the places I usually do. Uncle Bill's in Cosmic Lettuce, Space TV. All of you guys are on the live thing on YouTube, which is great. But I'm hoping you'll use Discord, which I've also got up. That's where a lot of our conversations about this have happened. Okay. So, what's the deal? What are we doing here? Why is Tony talking at me on Friday night when he should be doing Spaceman News? Well, okay, let me show you something. This is the screenshot of the Worldwide Telescope. Now, the Worldwide Telescope was invented or developed at Microsoft Research, not Microsoft Corporation. Microsoft Research is different and it matters. So I don't know. Anyway, they wrote this program and they put it out in the public domain It's open source, and it is now maintained no longer by Microsoft Research, but by the American Astronautical Society. So if you go to the link, there's a link in the description box, worldwidetelescope.org, and you'll be able to download it for free. It's only on Windows, though. So if you've got a Mac, you can't really use it. That's why I actually bought this laptop, for the reason that I can run this program and that and Space Engine. I also wanted to run Space Engine. Okay, so this is it. This is Worldwide Telescope. It is an app you can open up. Now, you can also run it on a web server, the web page, but that's not as nice. So you want to get the client if you can. Now, what it is basically a data viewer. You can see the sky from a variety of locations. For example, here I am looking at the sky. Well, I've got the constellations turned on, and the labels turned on, and you can see the ecliptic right there. The ecliptic is the path the sun follows as it goes across the sky. It doesn't really move. The Earth is rotating. That's a different story. So this is Worldwide Telescope. Along the bottom is a list of things that you can see in that current field of view. You can zoom in, you can zoom out, and I keep the constellations up so that I can keep track of where I'm at in the sky. And you can look at the sky. You can also look at the solar system. I lost my mouse, so I have to do this trackpad, and I hate it. Here's the solar system. You can go different areas. I tried to use this during the eclipse to show people what the sun and the moon and the Earth were all doing from a vantage point high above the Earth, to limited success. But if you want to see that video, go right ahead. Anyway, here's the sun. You can see the Earth and the moon over here, and we can go. You can move time forward, back really fast. Here is me zooming through, but it's not doing anything. So let me pause it. It usually zooms really fast when you. Oh, I know why. I'm not looking at a particular object. So anyway, there's a solar system view in here as well. But I'm going to go back to the sky view. Here's the sky, and this is what I was playing with the other night while I was watching Cosmic Lettuce. I was playing with this. And I went over to Orion, because Orion's high in the sky right now. And let me scooch over. I gotta find it real quick. I really wish I had my mouse, which I lost just prior to this stream starting. Okay, there we go. There it is. Okay, so there's Orion. And what you can do, and if you zoom in you can see different imagery in the background. Like, for example, here is the sky as it looks by the digitized light sky survey. That's an optical wavelength. But I could also, if I wanted to, look at this universe using Planck data. This is the cosmic microwave background. This is what sky looks like in microwaves. Now, this is boring, but it's cool if you're a cosmologist, especially if you want to study things like dark energy. So, but if I go back here, and you can see the Orion Nebula is very prominent in here, and along the bottom you can see different data sets that have been added. Like, here's a Hubble image that has been added superimposed over the Orion Nebula. Here's another Hubble image. Now, this gives you a really good idea of the field of view of Hubble. This is an old wide field camera, WIFPIC 2 image, because of you can tell by the staircase design. But this image is very small, because the Hubble's field of view is kind of small. And so anyway, this is what it looks like. This is what Worldwide Telescope gives you, among a great many other things. So I was up here looking at the Horsehead Nebula, and I zoomed in a little bit, and I thought, oh, wouldn't it be great? I would love if I could put the new Hubble image of the Horsehead Nebula in it. Now let me show you that. So if I go over here, so this was the image I wanted to put in, okay? And this image is Judy can tell you a lot about it too. But this image is an image using the Wide Field Camera 3 on the Hubble Space Telescope. It's in the infrared, and it is one of the most beautiful infrared images I've ever seen. And you can clearly see a lot of detail, high resolution in infrared. And I wanted this in Worldwide Telescope, so I downloaded it. You can see right here, it's got a little thing where you can download it. And I thought, okay, I'll download this image here. And this, by the way, is a site called AstroPix, which is supposed to have the images that works in Worldwide Telescope. So I download it and I try to upload it into Worldwide Telescope, only to have it not work. So I go to Judy, or I go to Discord, and I'm talking to everybody on this. And a lot of great image processing minds watch deep astronomy videos, thank goodness. And I put this out there. I said, look, can anybody take that image, that Horsehead Nebula image, and make it so it works with Worldwide Telescope? And 24 hours later, I wake up this morning, and Judy says, yeah, I got one for you. Here you go. And look, there it is. And this is the Hubble 23rd, I think, anniversary image of the Horsehead Nebula from Hubble. But look at this. Look what I can do. Check this out. There's a little crossfade right here. Now I can. This is what the Digitized Sky Survey shows. This is optical wavelengths. But look at the Horsehead in infrared. Check that out. Look at that detail. Look at those clouds. And, that's just unbelievably beautiful. And
you go real close into that blue area, you can see all these background galaxies.
All right, let me try it with my stupid trackpad. Okay. Whoa. Yeah. So see, look at the high definition here, folks. Judy, you got the highest resolution, right? The one with the highest resolution?
Yeah, I did.
Okay, cool. And look at this. Look at these clouds. It's like you're looking up in a cloud from Earth. I mean, look at the detail, the billowing features that you can see where stars are lighting it up from one side, and you can also see dark areas where stars are being occluded. And I just love this image. And here you can explore it in the Worldwide Telescope, oriented exactly as you would see it in the night sky. Now, obviously, you need a Hubble Space Telescope and a lot of data observing time to see this, but hey, it's right here. It's at our fingertips now. So the problem was, though, this is a JPEG image, and that's what Worldwide Telescope uses, is JPEG images. They also use FITS images, but I don't want to get into that in this hangout. But look at it. It's oriented. It's turned in the right orientation. Let me turn it off so you can see that this is the way it is in the actual sky. This is the optical view. Let me back up a little bit. See, there's the Horsehead Nebula, and if I cross-fade it in, there is Hubble's anniversary image. It's rotated properly, it's scaled properly, and it's right where it needs to be. So now if I move around otherwhere in the Worldwide Telescope, it stays right where it should be. This is a feature of Worldwide Telescope that people can, add their own data as data become available to this system and visualize it. Well, JPEGs by themselves aren't enough. We've all taken JPEGs with our cameras. We know all about them, but they have most images have a thing called a header. And since I've been talking nonstop, Judy, you feel like describing what a header is for people?
It's sort of, if you've ever, okay, that's making too much. It's like some extra data at the top of an image file that's sort of like HTML.
Yeah, that's a good way to describe. Sure. Yeah, that works.
You've ever made a website and you have to define the title of the website, that goes in the top. It doesn't go down in the body of everything that you see.
Right.
It's just this extra, the image is obviously going to be a whole bunch of numbers for each pixel, but then we have this extra data that lets us know, for instance, if your digital camera takes a photo, it will often embed this extra data in the very same way to let you know, what was the name of the camera, what type of lens did you use, what was the focal length, and that kind of thing.
Yeah, that's a good way to put it. In fact, if you really could, if you wanted to, you could actually open a JPEG image up in a text viewer and you get a lot of garbage, but at the very, very beginning, like the first line, you might actually see some text, and that text, because all they do actually have a header in it. It has the date, the time. Sometimes they put the location in where the image was taken. So even JPEG images from your digital camera have a header in it. It's just text information, actual text information that tells a little bit of information about the image itself, and it's embedded in the image. So if you think that when you post a JPEG on social media and you're being all clever about it and you didn't turn off this capability on your camera to put information in the header, smart people can take that JPEG and see information. Some of it might even be where you were when you took that image. It certainly have a date and time. So excuse me. Just be wary of that. But anyway, this header is a little bit, that we're talking about is a little bit more. It's actually called a AVM header. And this is something that was invented by people who want to use fancy, really beautiful science images, it's particularly astronomy images, in a science context. It stands for Astronomy Visualization Metadata. And it was invented by planetaria, science museums, NASA. A lot of people got involved in this as a way for science educators and communicators to use those really beautiful images that you see in the Hubble Space Telescope, but in a variety of different programs like the Worldwide Telescope. So, long story short, the JPEG that I wanted to use didn't have that header in it. And Worldwide Telescope looked at that JPEG and said, I don't know what that is. I don't know what to do with it. So what it needed the title of the image. It needed the URL from where the image was. But most importantly, it needed something called WCS data. And that's called World Coordinate System. It needed to know how to orient that information. So the contest, here's the meat of the contest. The contest is to take any image, preferably a Hubble image, because for reasons we'll explain in a minute. If you find the really pretty, the anniversary images are great. This was an anniversary image. And another one is the Eagle Nebula. The one they took on the 25th anniversary was even more awesomer. And so you can take that one as well. And then you got to get the information, the WCS information available in there to it. So I guess this is a good point where I'll turn it over to Judy. So she actually figured out how to do it. And it's not easy, folks. So don't be intimidated. We're going to make it easier. But for now, I want to go ahead and explain the problem. So go ahead, Judy. I'm going to show your we're now looking at your screen.
Okay. So I want to do I already did
looking at your screen.
The horse head.
No, now we're looking at your screen.
Okay.
Mm-hmm.
And I can't see anything. I don't know why. Earlier when you showed, I could see you and I could see what was showing, but I don't see anything.
Hang on. Maybe I forgot to turn on the virtual camera. Well, it's running. You don't see me.
It's okay.
I'm sorry. Well, trust that we are looking at your desktop right now.
And you saw the narrowband visible light image that I did, right?
Not yet. I'm sorry, Judy. I was so busy on Space Fan News. I haven't uploaded it yet.
Well, that's okay. Well, this one I haven't done yet. I did go over a little bit just to make sure that it wasn't going to be a problem. But here's another infrared view, but this is of the Pillars of Creation, and I'm just going to show you what I have to do in order to get this picture. If it doesn't have AVM data, then you have to add it yourself somehow.
And most of these don't. In fact, you can count on them not having it.
It's very tedious. There's no real automated way to solve these using astrometry.net, which is what a lot of people always suggest that. But with Hubble imagery, the field of view is very small. And with infrared imagery, even if you have a wide field of view, the stars look way different than they do in visible light, and it will often fail for infrared imagery as well. So one way to do this is you've got to download the original size image because you want to sort of match this up with the original FITS file and use the FITS header information, which contains WCS World Coordinate System data, and sort of convert that into AVN data. So I already downloaded these because I don't want you guys to have to wait. Looks like I didn't download that. That's not very big. I'm just going to save it real quick.
Okay.
I'm going to rename it HST Pillars Infrared. Save. I already did download this, and you do not need an account to use the MASS portal. You can do it anonymously. And if you just want to download a single image, which is all I need, then you don't need to use anything on this interface. But it is very confusing. I'll show you what happens when you just MASS load up a new instance here. You want to search for the Eagle Nebula, and you know it's Messier 16, so you can just search for M16.
Yeah, but don't you want to also use the prop ID to get the right images, or no?
You can, but maybe you don't know the prop ID.
Well, you could get it from FastFacts on
Sure.
on Hubble site.
Sure.
So the prop ID is just the proposal ID that that Hubble used to take the data.
This one. 13926.
Yeah. So if you search on that, you'll get only those images that came from
You
that.
have to use the advanced search in order to do that.
Yes, you do.
We'll go down that. 13926. Search. Let me close this one down because it got extra footprints
Okay.
scattering everywhere. Okay, this looks a little more familiar, a little less stuff in the way. Can you see my mouse cursor?
Uh-huh. Yeah, it's small, but we can see it. And I may zoom it in a
Yeah,
little
so
bit while you're talking.
you can see here, these are called footprints, and this is the outline of the frames of where the telescope looked. And you can sort of see, like, here's one square here, here's another square here. But there's also the ones down here. And the reason for that is Hubble does simultaneous observations. They call them parallel observations. So while it's looking down here in the infrared with one camera, it's looking up here in the corresponding location with another camera. So that's why there's two of those.
Yeah, so those are all the different areas that Hubble was looking or took images of in that area of the sky.
Okay.
So what she's doing is you found that you want to look at the Eagle Nebula. You got to get the actual Hubble data to figure out the rest. So she's gone onto the archive for Hubble data and typed in the target name, which was the Eagle Nebula, and the prop ID, the proposal ID, to get the images that were used to build that really gorgeous Hubble image.
And this is kind of painful here because the Eagle Nebula it's hard to see. You have to kind of know that it's there.
That little window is not going to show you much. Don't rely on it. Just know that
you do have to use it to get yourself oriented. It does. It's very helpful.
Oh, do you? Okay.
It's just you can change it to. Let's see if we've got any other. No, you really need the DSS blue data, and I can't. Well, can I? No, it's not in there because the blue data shows it's a lot less bright and overexposed. The red channel is very anyway. So this is the lower right corner of that Eagle Nebula. And in order to clean some of this up, I know my camera that I'm using. I guess I'll show here that this is back at the Hubble site at the FastFax. We're using Hubble Space Telescope WFC3/IR.
Those
And
are
that's
the
the infrared
instruments. Yeah.
channel on the Wide Field Camera 3. So we don't want to see all these other cameras that are involved in this proposal. So I'm just going to click that one. And it's a lot cleaner now, right?
Yep. Look at that. Now you've only got a handful.
Yeah. This big one is actually a mosaic that was put together. I'm not really sure that the WCS data, the coordinates on that, are as good as the original exposures. These would be, I guess, closer to raw. There's still multiple exposures stacked, but the coordinate data is more correct. And I did check that. I thought maybe I could just use this beautiful pre-made mosaic. Yeah. You can see in the thumbnail here that it's the whole thing. It's not just the corner piece.
Okay.
But it didn't work. It was way off. It was like down here somewhere.
Oh no.
And I don't want that because that's really, you want to get it pretty close before you start tweaking it. So I'm going to use this corner here. And I'm going to I click this and download it and save it to my desktop. But I already did that because it's a couple hundred megs. And I don't want to wait.
Right. So the little
So I've already
checkbox
got
lets
that.
you select it for download, and then you get it on your desktop. Now what you've got is a
I
fits
didn't
image.
even use the cart. If you click this icon here,
Yeah.
so
Okay.
annotate this little guy here.
A couple things I just want to get to. Alex Despland is asking, does it let you change the point of view and see what the universe likes from another star? Yes, WWT does that. I'm just only showing you for the purposes of this contest here. And where can you get the Space TV? Where can you get the image? All of the links that what we're talking about is in the description box. Okay, so go to that Astropix. Go to the Astropix URL, and you can download the image I was showing you. And where Judy is now is on the Mast Archive, which also the link is in the description box.
Yes, my favorite website, the portal website.
Right. Yeah, you spend a lot of time here, I'm sure.
Sometimes I feel like I spend more time than a scientist. But anyway, so this is Fits Liberator.
Okay, real quick, what you're going to get from there is a FITS image. If you don't know what a FITS image is, that's fine. It's just it's a scientific image. It's got the data that were taken from Hubble. It's also got a header on it. And what she's doing, she has a piece of software called FITS Liberator. It's also free, and it can read that image. And so you can also download that.
If you search for Fits Liberator, it comes from ESO's website, and they're the ones who developed it, and it just makes the process of extracting FITS data and converting it into a TIFF file, which is much more familiar to most people who work in like the creative industry. Everybody pretty much knows what a TIFF file is. It's just a very
this is a
old
viewer
and common file format.
Right. So once you've got it in here, what are you using FITS Liberator for, Judy?
I need to save the image into a format that Photoshop recognizes. Photoshop will not natively open a FITS file. And
So what are you saving it as?
also, it only exports as TIFF.
Oh, TIFF. Okay.
Yes, TIFF. And also, when you first open it up, it's going to look like this, probably. This is a 1-to-1
Scaling.
linear scaling, and you can't see diddly. That's just the way the space images are. But yeah, I already stretched it out. You'd have to play with that. So you just save it.
Save it as a TIFF.
Go ahead and save it as a TIFF. And in fact, you can now try to load that TIFF up into Worldwide Telescope. And I do notice there is a small hitch with this I don't know why. Does Worldwide Telescope take this long for you to load too?
Yeah.
It takes me forever.
Yeah, it takes a while. Part of it is it's actually doing some stuff, checking on the web too, but I don't know why it does that.
So I open that FITS file, which is now a TIFF file.
So you go to Explore, Open, and then Scientific Image.
Yep, astronomical image.
I'm sorry, Astronomical Image.
Open it directly in, and it puts it in there, but it's for whatever reason it's flipped. It's flipped horizontally.
You mean to tell me you could just export that as a TIFF image from FITS Liberator and get close?
Yeah, pretty close, but it's look, it's upside down.
Yeah, I know that's weird, but
but it's real easy fix for that. Open it in Photoshop. Just I don't know, do anything, undo, and then save it. And for whatever reason, when I resave it,
I wonder if it's Little Indian. I wonder if it's
it could be something with that. It could be like reading them backwards.
Yeah,
it seems backwards.
Might be byte swapped.
I just renamed that file because something about Worldwide Telescope, when you load the image, it caches it. And even though you change the image and you reopen that same image, if it's the same file name, it loads the cache. So you need to rename it every time you reload it.
That is a pain.
So I just put a 1 on the end.
Okay.
And now it should be flipped there. And now it's really, really close.
That is nice. That's not bad. How close is
that? You
that?
can see this star here, it corresponds to this.
Oh, hell, Judy, that's close enough, man. It's not perfect. I get it. But, I mean, if I were going to be doing an educational thing, this is like close. Okay. Well, that's
pretty close.
That's really cool.
It's not like but unfortunately, it's only this one tiny window here.
Yeah.
And if only that mosaic that was in the archive would work. But I did try it, and it went way down here, unfortunately.
Oh, okay. So you do still need to figure out
the
coordinates.
Way over here, and it was just not at all useful.
Okay. All right.
So what we need to do is find a way. The way the I can't even think of what it's called. The AVM. This is actually a spreadsheet showing exactly what the AVM data is made of, and I had to look that up. But the AVM data, it takes the coordinate. It needs first of all the right ascension and declination. It needs a point within the image called the reference pixel. It needs to know the size of the image, and it needs to know the scale, like how much of the sky is each pixel. And seriously, the scale is in degrees per pixel, and that is really, really, really small per pixel for Hubble.
Okay.
So it has to be it's a decimal place with like 4 zeros in front of a number to get the pixel scale for this, and all sorts of funny things that I had to figure out. So how do we convert the metadata that is in this image and add it to this one?
So how did you do that?
Where things start getting fun.
So, okay, I guess, yeah, go ahead. What, do you want to stop here and maybe come back after we've worked out this procedure a little bit more?
What do you mean?
Because doesn't it involve getting, would you say, pinpoint?
I can't get pinpoint. In fact, I learned that people are unable to use pinpoint even on their latest version of Macintosh.
Oh, okay.
They're actually saving their old versions of their operating systems on their Macintosh so that they can still use pinpoint. So it kind of unearthed something here that is a problem.
So we've stumbled on something that no one's really supporting. It sounds like a little. People have kind of
it needs to be supported though, because we're possibly about to lose a resource because whoever was developing it stopped developing it, and somebody else needs to pick it up. But No, I don't need to do anything else. I actually, oh, you're right. I do have the file info
Right.
originally in Photoshop. This will not show up. This is the astronomy. These are the AVM headers here in Photoshop.
Okay.
And these are all we need right here.
Oh, okay. What are you pointing to? I want to make sure people can see. Let me scale this up a little bit.
Annotate this. I am pointing to these numbers here. We need this
So
too.
these are these spatial values are what we need to get out of the FITS header. Oh, they're already in there. So
This came from the original FITS file that I took in from FITS Liberator and opened it as a TIFF. And FITS Liberator is so wonderful, it automatically converts WCS data into AVM data.
So the act of going from a FITS file that we got on the archive and saving it in FITS Liberator as a TIFF gave us the AVM header that we needed and a lot of information that was actually quite close.
Exactly.
Okay.
Exactly.
Now you then took that TIFF image and opened it up in Photoshop and we see this.
Mm-hmm.
Okay. But it's not quite right.
We have to convert it.
Okay.
What I will do really quickly is, okay, you can export this so you don't have to copy and paste it one by one. You can export this and save that, please, because I already did it earlier. And now take it over into your other image by importing it. And Photoshop is nice because it automatically lets you do this. Just clear whatever's on there and overwrite. And now
It's in there.
it's in there.
Okay.
We could try saving it and see what happens.
All right.
I'm going to rename it once because I'm not sure if I already opened this in the Worldwide Telescope.
All right. You got to do that clearing business.
Yeah, that's frustrating.
So WWT still needs some work in some areas.
Yeah.
There it is.
And you can see it's kind of close, but there's some issues. The scale is wrong.
the dissolve, the cross
Okay.
dissolve. Let's see how that looks.
This is like, you can sort of see this. This is the
Yeah.
second pillar, and this is the second pillar. So
Okay. Nice. Okay, I want that
so
image.
it's getting there.
Yeah.
I mean, it's rotated the correct, exactly right. It's rotated exactly right, but it's just a little offset, and the scale is a little wrong.
Okay. Thank you, Judy. Okay, I'm gonna just stop right there and okay, all right. So this is the contest. Pick a Hubble image. I know that this is not something that anybody can do, but some of you can. And use this video as a short guide. I mean, it's watch it again, and by all means ask me any questions you want. And if Judy's around, I'll bother her about it. But I don't want to offer her as a resource, and I will filter some questions through her. I'm on Discord all the time on the Deep Astronomy Discord channel, so just please ask your questions there. Leave comments on this stream, and let me know what you think, and if you can make an image that is even close to fit up in a WWT, I'll give you a t-shirt. And the links to all that is in the description box. All of the links, except to FITS Liberator, and you can just look that up, is in the description box of this video, including, and if you just want to use the same Horsehead Nebula that I had before, go ahead and do that too. So anyway, had this idea while I was watching Cosmic Lettuce. Thank you for that idea. And I know you're getting ready to start your stream soon, so I'm gonna cut out. I'm about to post Space Fan News and look forward in about 15-20 minutes. I just need to get the captions and stuff put up. And Judy, thank you for taking time out to talk to us and show us what you did. Also, thanks big time for getting that image ready for WWT. I do appreciate it. Listen, I want to make it available to people, but I don't know if it's cool if I give out the URL to your website. Are you okay serving the image, or should I put it up on my website?
If it's a smaller one, it's okay.
It's the
I think
one
it
you
was like,
did earlier today that was on your website.
I don't know. If you're not sure, I don't know how many people. It's not that many, right?
I don't know. I don't think so. But
You can
I
just
tell you what, I'll put it on Deep
I might
Astronomy.
delete it or something. So just go ahead and take it.
Yeah, yeah. All right, I'll put it up and I'll give proper. Well, I kind of want the one with credits in it though. So maybe we can fill out the rest of the information.
Yeah, I can fix that.
Yeah, thank you. And then also put a URL to where people can get the image because that's credit to the institute. So they need that as well. So yeah, if you can fill out the rest of the header, then I will serve it and I will let people know where to download it and put it into their own version of WWT. And then eventually I'm going to reach out to the WWT folks and see if they want to incorporate it into their builds. So anyway, thank you, Judy. This has been a lot of fun. I hope this is something that gets you guys stimulated. It gets you guys involved in astronomy. I know it's not a beginner activity, but not everything has to be beginner activity. You got to start, this is image processing. This is how astronomers do work. And one of the biggest important points of an astronomy image is where in the sky is it? And that's called astrometry. And it is a vital part of being an image processor, and the header information that it's all stored. We just got to get
How
it.
you say that word?
Huh?
I said,
What?
You say astrometry?
I say,
I've
yeah.
never heard that word, and I said it astrometry. and
Astrometry. Well, I mean, that's fine too. But yeah, astrometry is how most astronomers say
astrometry.
it.
Okay, thank you.
Yeah, no worries. And so yeah, and so getting that information is vital. That's all you're doing. You're getting it from a JPEG image that's on that AstroPix website that doesn't have the header information. You're just putting in the right header information. So if you could do that, awesome, and you'll get a T-shirt. So let me know. And Cosmic Lettuce, it's on you next, okay, bud? I want to see yours. Lots of different ones to do. Quick question from Alex Despland. What's the difference between Worldwide Telescope and Google Sky? They're not the same program. So they use data sets, or at least Worldwide Telescope tries to use data sets from observatories from around the world in different wavelengths. You can get Chandra data. It's got Chandra data in it, Spitzer data, Hubble data, obviously, and Sloan Digital Sky Survey data. That's lots of surveys. So they just are different, but I guess they do the same thing. Anyway, okay, guys, thanks for watching. I'm getting ready to post SFN now. I will check in next week, maybe do another live stream, and we will go from there. Anyway, thank you all so much for watching, and as always, keep looking up.